that any of you can take advantage of. So let me start by saying, look, most of the technology we have built, most of the software we have built up until now has been for the Internet of people, right? So whether that's an ERP application or search or e-commerce or any of these types of software, we believe at the end of the day, what you're talking to is a person, us, right? And my Stanford students pay a lot of money to hear the next thing, so you're going to get this for free, right? So things are not people. Things are not people. People are not things. So I'm going to give you 5 reasons why things are not people. Okay, the first, and you may have already heard this, John Chambers, who's the former CEO at Cisco, has been widely quoted as, there are going to be 500 billion things connected to the internet. Well, if that number is correct, that is literally 100 times the global population, right? Way more things than people. I was speaking with the CIO of Extension Health. It's one of the largest healthcare providers in the United States. And he said to me, hey, it's happened in the hospital as well. There are way more things connected than there are people. 1. 2, things can be where people are not. Things can be where people are not. Things can be in your stomach. You may have heard of smart pills. Things can be a mile underground in a coal mine. Things can be out in the middle of the desert. Things can be where people are not. Okay? Number 3, things have way more to say, right? If you think about it, all of us, well, we can type a little bit, move a mouse around, click a little bit. You may not be aware of this, but modern day wind turbines have nearly 500 sensors on them. 500 sensors that actually spit data out once per second. So they have a lot more to say than we ever could. 4th, things can say it much more frequently. There's a machine in the coal mining industry. It's called a longwall shearer. It's actually about 2 football fields long and 30 meters high, and it basically digs through a coal seam a mile underground. As it's digging through the coal seam, it forms what's called an artificial roof, and what they want to make sure of is that the roof does not collapse on the machine, because if the roof collapses on the machine, they have to go dig it out. Their $100 million machine, by the way. So they put sensors on top, vibration sensors. These vibration sensors sense at 10,000 cycles per second. That is way faster than anybody can ever type or click a mouse. So things can say it much more frequently than people. And the last, and we can debate this, is things can be programmed, people can't. Right? So fundamentally, if you believe that things are not people, then why would the technology that was built for the Internet of People work for the Internet of Things? Which is why I think we stand at the beginning of a whole new set of opportunities. So what I want to first do is talk you through what is happening technologically. I'm going to use a fairly simple framework, this is actually in the book, to describe all of IoT. We're going to talk about the things themselves, how these things are connected, what do you do to collect data from them, what can I learn from that, and then finally, what would I do differently? Now, right off the top, I'll make a point. In the world of the Internet of People, we actually had to build applications so that you'd want to type data into them so that we can run a bunch of analytics to figure out stuff about the data. In the world of the Internet of Things, I do not have to entice the machine to talk to me. It's happy to send me data all day and all night. So I can learn before I do something, which is entirely different than we did last time around. So what I'm going to do is I'm going to take you through each of these major areas, talk a little bit about where we are today, and talk a little about what the opportunities are for the future. So I'm going to start at the top, which is, why is this all happening? Well, sensor technology is getting cheaper and cheaper and cheaper, and it's driven by one thing, which is what's sitting in all of your pockets, which is your cell phone. You probably are not aware of this, but every cell phone out there has at least 12 sensors on it. At least 12, right? There's actually a cell phone in Japan that has a radiometer on it, of all things, right? You can guess why. Okay, it has 12 sensors on it, which is why, at this point in time, accelerometers, which are pretty sophisticated sensors, actually quantity one cost about $2, right? So we can put sensors in a lot of places for no money, okay? And at the end of the day, if you start thinking about it, right, and what's the implication of this going to be to things? Well, most of the machines out there today, if you go look at a tractor, a gene sequencer, any of these, from a computing point of view, they are very unsophisticated, right? For those of you who are engineers in this area, PLCs, small microcontrollers, they're very unsophisticated. Now, I'll point out something, right? If you picked up your cell phone, well, I have my cell phone over here. You think about it, what is this? It's got 12 sensors on it. It's got a big computer. It's got a lot of memory, a lot of storage, and it talks to 3 different networks. And if I took the fancy case off of it and the fancy display, it probably cost about $50, right? So the question I've been asking people is, when are we going to see a cell phone inside every machine? Now, I was theorizing about this about a year ago. I made a comment, I teach at Tsinghua, so one of the things I do is I go talk to some of my former students just to see what's going on. So one of my former students is at Xiaomi. I don't know, how many of you guys ever heard of Xiaomi? Okay, a lot of you. Okay, so Xiaomi is the world's largest cell phone manufacturer, right? They manufacture cell phones for the China market. Amusingly enough, they are saturating that market. So they're actually right now trying to figure out how to go to India and other places. But the other thing they're doing is they're starting to think about new products, right, beyond cell phones. So I said, well, like what? So my friend says, oh, well, let me show you. And this is a product that if you know the China market, you go, oh, yeah, it's obvious. So he showed me an air purifier, right? So if you're aware of the Chinese large cities, that the air quality is pretty bad. So they are selling air purifiers. If you open that air purifier up, guess what you see inside? Cell phone. This is not too surprising. If you know the history of Xiaomi, the vice president of engineering is a guy named Hugo Barra. Hugo was one of the original engineers at Google working on Android. He moved to Xiaomi now 5 or 6 years ago. Actually, he just moved back to Facebook to work on VR, AR stuff. So it's not too surprising if you would see a cell phone inside that air purifier. And I think as we move forward, the level of technology we're going to see inside these machines is going to be tremendously different than where we are today. Let me just give you a simple example of this. I happen to like cars, so Porsche's Panamera, which is their fancy luxury sports car, the 2016 model of this car had 2 million lines of code in it. 2 million lines of code. The 2017 version of this car has 100 million lines of software in it. In the medical instrument world, even an MRI scanner has north of 7 million lines of code in it. So the advent of software-defined machines is getting closer and closer, and it will change what these machines, these things look like from where we are today, and we'll come back to this later. Okay, so that's the thing itself. Gene sequencers, wind turbines, air compressors, right? So how are you going to connect to these things? Well, in the world of the Internet of People, we've been pretty happy with, oh, give me a little Wi-Fi, you got a 3G, 4G network, and I'm pretty happy, right? Well, remember, I made a point that things can be where people aren't, right? So I'm going to give you an example. There's a patch made by a company called Sensia Vitals. So it's a vital sign monitoring patch. So they put it on you when you go into the emergency room. It monitors heart rate, respiration, those sorts of things, right? As part of the design criteria, they said they didn't want to put rechargeable battery packs on this. Because if they did, they would have to wash the battery pack, they'd have to recharge it, they didn't want to deal with that, right? So they decided to go to disposable batteries. As soon as they went to disposable batteries, they couldn't run Wi-Fi. They didn't have enough power. So they ended up having to build out for those of you in data communications know, what's referred to as a Zigbee mesh network, but a network which allows for them to transmit with much lower power, albeit at much lower data rates. So I think today, what we'll see in the world of IoT will be a much greater diversity in communication connection technologies, right? They will be much different by virtue of how much data you're trying to push through them, how much power you're going to require to do that, and what range needs to be applied. So some of you may be aware of things like Sigfox, LoRa, these sorts of technologies are all in the category of much lower power requirements and much lower data rate. I'll go to the other end of the spectrum and say, we're going to need technologies that are going to transmit tons of data, right? I always like to ask people, what do they think the most demanding networking application is out there? Anybody have a guess? Actually, I have no idea. You guys probably never see this. Well, it's probably a toss-up between the World Cup finals and the Victoria's Secret runway model show, right? Those probably are the most demanding networking applications out there. Now think about what that means. We're taking a ton of data sitting up in the cloud and we're pushing it down in through the network to the endpoints. Now let you think about, right now, wind turbines, I just made this point, 500 sensors on them, data coming off once per second off those 500 sensors. There's a company out there right now that has 15,000 wind turbines in the field. Now think about all that data being generated, and I want to push it up into the cloud. So maybe we're going to have to end up building reverse streaming networks. My only point, the networking problem, the connection problem is far from being solved to the Internet of Things. Okay, so let's assume I cracked that problem. The next thing I have to figure out is, well, how am I going to collect the data? Right? Well, most of you who've had any computer science classes know about SQL databases, right? So I'm going to store this in a SQL database. And at the end of the day, I'll go be able to do analysis on it by hiring a bunch of data scientists who are going to sit there and, visualize the data and figure out what this all means. Right? But I don't think it's going to be that easy. So there is a oil drilling platform off the Gulf of Mexico right now by one of the largest oil companies in the world. That oil drilling platform has 40,000 sensors on it. 40,000 sensors. So I'm talking to the oil and gas company. I said, well, what are you guys doing with all that data? And they go, oh, it's easy to explain. It's all digital exhaust. Digital exhaust. It's just going into the air. They're not doing anything with it, right? Why? Because it's pretty easy to calculate how many disks I'm going to need, how many licenses I'm going to need to store it in some big SQL database. By the way, 15,000 wind turbines generate 750 terabytes of data per year, right? It's a lot of data, right? So if I go to my boss and say, hey, I want to buy enough storage to archive 750 terabytes worth of data, it's going to be a big number, and she's going to look at me and go, well, what are we going to do with it? And at that point in time, I'm going, well, I don't really know. Because the analytic approaches that have been applied to date really depend on the idea that humans have some intuition about the data. Now I sit there and go, well, if I've got 15,000 wind turbines, knowing the barometric pressure every second, what intuition am I going to have about what that data means? And we're not going to be able to crack it the old-fashioned way. Instead, and I very much encourage any of you who are interested in this, we're going to end up, in my opinion, starting to use computers to do this. Artificial intelligence, machine learning, advanced analytics. So what do I mean by this? So I don't know how many of you have been paying attention to the revolution that's happening in AI on the consumer side, but let me talk about it just for you to think about it. There's a competition called the ImageNet competition. That competition is between humans and computers as to who could recognize an image. Okay? In 2011, the computers were about 65% accurate in being able to identify the image. Humans were 93% correct, okay, in identifying the images. 2 years ago, the computers hit 95% accuracy. They were actually better than humans, right? Some of you who follow this have heard about DeepMind and the Go application, right? So Go is widely believed to be a game that was going to take years for computers to be able to beat humans at. And it happened actually last year, right? So why, and if you're at all playing around with Siri or Alexa or any of these voice assistants, you're starting to see how accurate they are in being able to recognize your speech. I know all of you have Facebook accounts, so you probably all have seen how good they are at facial recognition, right? Why is this happening? Why is this getting to be so good so fast? And I'm going to tell you, it's 3 essential things that are coming together. First of all, this technology, which some of it's been in development for 20, 30 years, right? And by that I mean deep learning technologies, neural network technologies, now being exhibited inside open source. Some of you are aware of the work that has been going on in something called TensorFlow, but these algorithms are starting to become available to people fairly simply, right? 1. 2, they require tons of computational horsepower. Remember I said 10,000 computers for 30 minutes for $3,000? Well, I now have access to tons of computing for no money, number 2. And 3, access to tons of data. So why did DeepMind, why was it able to do so well? Well, actually they had 1 million Go games to analyze. Why is Facebook facial recognition work so well? Well, now it should be pretty obvious. They have tons of faces to look at. So the coupling of these 3 things is dramatically accelerating the progress in this space. My personal opinion is this is going to be reaching over into the world of things because we have the identical problem to have to crack. So any of you guys that are interested in this stuff, or math majors or whatnot, go learn more about this area. The change is occurring very dramatically, and it has implications not only to the Internet of Things, but to many more. Okay? So, learn. So finally, what are we going to do about it, right? So, what is going to change? Well,